Hello, this is the second part of Chapter 9, Chapter 9 Part B. I hope you're still doing well. So let's get started. So last time I talked about these sections here, systems of linear equations with two variables and three variables, and I want to just go over it, maybe review it one more time and do two application problems. And then I'm going to talk about systems of nonlinear equations and inequalities. We're going to do some problems from that section. Now, last time I kind of went over these three different ways of solving the systems of linear equations using matrices, Gaussian elimination, systems in using inverses, matrix inverses, and the Cramer's rule. So I'm just gonna quickly go over that review and then do some application problems. Then we get to systems of nonlinear equations and inequality. Okay, so so let me first of all go to an application problem I want to do. So here we go. Now, before I do that, let me kind of review quickly. Let me get a wide area so I can review. Let me get that. So that's good. So what I want to do, I want to review what I did last time, and that is, if we have a system of linear equations, I could just write whatever, doesn't matter, as long as something like that, right? So as long as the slopes of these two lines are not the same, you're going to have a solution, right? If the slopes are not the same, you're going to have a solution. And if the slopes are the same, we talked about that, you get the same lines, so there's infinite number of solutions. And then if they're actually, the lines are the same. If the slopes are the same, but they're not the same lines, that means they're parallel, so there is no solution. So we talked about that there is either one solution, none, or many. So how do we solve these? There's three ways to do it. First of all, we write it as a matrix, right? So we're going to write 2, -1, 1, 3, and then multiply it by xy, and then equals to 5, 1. Right? And then what we do is, basically there are three ways to do this. One way is using Gaussian elimination. Gaussian elimination says just create a augmented matrix like that, and then convert it to what? Well, let's do it with a calculator. We're going to convert it to RREF. So let's create a matrix, and the matrix has to be 2 by 3, 2 rows, right? So we have two rows and 3 columns. So what are they supposed to be? It's supposed to be 2, -1, 5, 1, 3, and 1. There. So once we have that, we get out of it, we quit, and then we go back to matrix and we go to math. Make sure you get out of it first. If you don't get out of it, then calculator thinks that you are trying to input in one of these entries if you don't get out of it. So you get out of it first. Once you edit it, go to matrix and then math, and then you go to RREF, and put the matrix in front of it and solve, and then we're going to convert to fraction. So that's the solution. So we got the solution here. We converted it to RREF, and this one has a solution. So we got 16 over 7 and negative 3 over 7. That's one way to do it. Another way to do it is to think of this matrix as A and this matrix as B, and think of this equation as AX equals to B, and X is this matrix, A is this matrix, and B is this matrix. And then we say X equals to A inverse times B. You put the A inverse on the left of B. So we're going to go ahead and create a, again, matrix A. We want it to be 2 by 2, 2 by 2. And our matrix A is just that, right? 2, right? Not 3, 2. And negative 1, 1, and 3. Okay, so, and then we get out, we want to create another matrix. We go to B and make it 2 by 1. It's already 2 by 1. So we put 5 and 1 there. And all we have to do is go to home screen and go to matrix and get matrix A and take the inverse of it and multiply it by matrix B and convert to, and it's the same answer, right? See that? It's the same answer. So we get a 2 by 2 matrix, that is, 2 by 1 matrix, which is 16 over 7, negative 3 over 7. All right. And another way to do it is the Cramer's rule, and the Cramer's rule says that X equals to the determinant of the A matrix, and then Y equals to, again, determinant of the A matrix, so the denominators are the same, and the numerator is the same determinant except for the first column we're going to put 5 and 1. So 5 and 1, and the rest of it is the same. And for this one, the second column is going to be 5 and 1, but the first one remains the same. There. And if you find these determinants, this is 5 times 3 is 15, minus negative 1 times 1 is negative 1. 15 minus negative 1 is 16. And that's 2 times 3 is 6, minus negative 1 is 7. Now this one, 2 times 1 is 2, minus 5 is negative 3, and the other one is the same, right? All right, so that's the 3 different ways using matrices to solve systems of linear equations. You can do this with 3 by 3 as well. So if this is a 3 by 3, this would be determinant of 3 by 3. Now, finding determinant of a matrix by calculator, basically you go to matrix and you go to math. You see it says determinant. You can find the determinant of a matrix. For example, determinant of matrix A is 7, and it finds it for you. Now for 3 by 3, there's a formula to do it by hand. We don't, you probably learned that in college algebra, and if you need it later on, you can look it up. But for now, we're not going to do that. If you get a 3 by 3 and you have to do it with the Cramer's rule, you can use calculator to find the determinant if it's 3 by 3. All right, so this method is superior to all of them, this right here. Because with this method, we know if there is one solution, obviously you get this structure here. And if you have no solutions, you get a row of zeros except for the last number is not 0. And if there is many solutions, you get a row of zeros, and that means there are many solutions. So it's a very, very useful method to solve systems of equations. All right. So what I'm going to do is I'm going to close this and go back to this problem right here. We want to do. So what we want to do this problem right here. But I'm going to take some more space so you can write on. So let me go up a little bit so I have some space available. So so we're going to do number 58. It says a cell phone factory has a cost of production of that and the revenue function of that. So you know, cost means how much it's going to cost per unit, and then revenue is how much money you make per unit when you sell it. So revenue is price you sell it at times number of items you sold, and then cost of how many you produced is that times how many to produce plus that. So there's a flat charge there. So what we have here is that 150x plus 10,000 is our cost. So I'm going to write it this way because I want to think of it as a system of equations. And then 200x is our what? Our R of x. Right? Now you can think of these as y's, right? It doesn't matter. Instead of you know, y, we can have c. So I can just erase these and just think of this as c equals to that. I mean, not c and r. We get to y equals to that and y equals to that. Now we know this y is cost and this y is what? Revenue. Now, what do we know about these two y's? Obviously, we have two equations and two unknowns, but it's really easy to solve because you see, how do we go about solving this? Well, we can solve it the same way we solved other systems, right? We can move the y to this side, move this number aside, move this, and then do it. But notice that the y is already solved, right? So y equals to that and y equals to that. So that means if the y's are equal, these two have to be equal. So we can set them equal to each other and solve it. So if I set this equation equal to this equation, we get the answer, right? So basically it's the same thing, but you know, with an application problem. Now, instead of doing it the way it is, I'm gonna move the y to this side and move the number to this side, move the y to this side, and then write it in a way that we can use a calculator and do it quickly. So let's see, 150x, right, minus y has to equal to 10,000, 10,000. And then 200x minus y has to be what? 0, right? Because if I move the y here, this would be 0. So let's see if we could do with a calculator the same way that we did. What is the matrix of, what is the augmented matrix? It would be 150, -1, 10,000, and that would be 200, -1, and what? And 0, right? So so let's see if we can do it this way. So we get a 2 by 3 matrix, and we have 150, -1, 10,000, and then 200, -1, and 0. There. So we get out of here, and then we go to matrix, go to math and find RREF, then go back to matrix and get the matrix, and then press enter, and then So what we got here is what is 240,000. Now we got negative numbers because we move them to this side, right? So what we have is, so here, so let me go back to the matrix A. So in the matrix A, we put 150, negative 1, 10,000, and 200, negative 1, and 0. So, so we assume that the y's are equal here, right? And then, so that means C and R are equal, so we just let them be y and they're equal. So the answer here is basically 240,000. So that would be break-even point. That means when C of x equals to what? R of x, right? That's the C of x and that's R of x. When they're equal, so for this to be equal, for these two equations to satisfy, the two numbers that work are 240,000. Now, what is, so we have to put x in here, right? And if x is 200, right? Y is going to be what? Y is going to be 200 times that plus 10,000 is going to be 40,000. Also here, if you put 200 here, y is going to be 40,000. But remember, this y was revenue and this is the cost, right? All right. So so let's do another one. So let's do another one. I want to get rid of that. And then we're going to do this one. Now this one says that we have, let me get some area to work on. So this one says a local band sells out for their concert. They sell 1175 tickets for a total purse of $28,112.50. The tickets were priced at $20 for a student ticket, $22.50 for children, and $29 per adult. If the band sold twice as many adult as children tickets, how many of each type was sold? So we are given information about three variables. X is, let's say, number of student tickets, Y is children tickets, and Z is adults. So what do we know? Well, we know that number of tickets of each when they sold, we don't know how many of each, but if you add them, we get 1175. So that's one equation. And notice we have three variables. In order to be able to solve all three, we need three equations. So we need one equation for every variable that is unknown. So one equation is this one, we know that. Now we need another one. How do we find another one? Well, another one is that the total amount that I sold, the total amount is $28,112.50. But where does that money come from? Well, that money comes from selling X number of student tickets, each of them is $20, plus Y number of children tickets, which is $22.50, and plus Z number of adults tickets, which is $29. So all of that has to add up to that number, 28,112.50. So that's our second equation. And the third equation is given here. It says, if the band sold twice as many adult tickets as children tickets, twice as many as adult tickets, so that means adult tickets is 2 times what children tickets. So that's another equation, and we want to write it right there, right? I want to write it right there. Okay, so this is the system, but it's not organized the way we like it. So the first equation is good, is x plus y plus z equals to 1175. That's good. The second equation is good, 20x, make this 20x plus 22.5y plus 29z equals to 28112.5. But the last one is not the way we like it. First of all, there is no x, right? Because there is no x here. So I'm just going to move let the x be 0. So I'm going to move to y. But what is y? Let me see. So what is y? Now if we move y to the left side, it would be negative 2y. So it's negative 2y. And then z is going to stay there. I'm going to leave it over here. So move the 2y to this side. It's going to be minus 2y. And then plus z, right? Plus 1z equals to what is left here is 0. So that's 0. So that's our matrix. Our matrix is going to be what? It's going to be 1, make this bigger. So it's going to be 1, 1, 1, 1, 1, 7, 5. And this is going to be 20, 22.5. 22.5 and 29, and then this big number 281112.50, and this is going to be 0 for x, negative 2 for y, 1 for z, and 0 for the number on the right. Well, that's it. So let's put it in a calculator and find the answer. So the main part of this to write the correct equations, and the rest of it is easy. This is a 3 by 4. So we got 1, 1, 1, and 1175. Is that right? Yes. And that's a 20, 22.5, 29, and 28,112.5, and 0, negative 2, negative 2, 1, and 0. There. We're going to quit, go back to matrices, math, get the RREF, go to matrix, get matrix A, enter. That's it. So we got what? We got, we don't have to draw the whole, well, let me do the whole matrix. So you see 1, 0, 0, 500, and then 0, 1, 0, 225, then 0, 0, 1, 450. So this is our x, y, and z. It's very easy to solve once you write the equations correctly, right? 3 equations, 3 unknowns. In application problems, you don't always get one solution, you might get infinite number of solutions. There are many applications of these. For example, if you have maybe a bunch of streets and intersections, you go to every intersection, see how many cars enter this way, how many cars enter this way, how many cars maybe leave this way, right? How many cars, leave this way, how many cars leave this way, how many cars coming this way. And if you have those numbers, you can actually write, maybe this one is that way. So you can actually write how many cars come in and how many cars go out. And if you don't want any jam, any cars jammed up at the intersection, what do you have to do? Well, you have to make sure that the number of cars coming in is equal to the number of cars coming out at every intersection, and write equations for them. And if you have 4 of them, then you have 4. So you're going to have 4 equations, 4 unknowns, and you can solve it using this method right here, because you want all of those to have no jams, right? No traffic jams. So what you have to do, you write a system and then just call these variables: number of cars coming in here, number of cars going out, number of cars coming in, number of cars going out. All of those are going to be converted to a system, and that's how our automated traffic lights actually work. So all this information is in the computer, and computer tries to find solutions for these so that you have no traffic jams. How can the computer affect this situation? Well, the computer can change the timings of these lights at the intersections, and by changing the timings, you can actually control the traffic in a city. Some downtown, like downtown Houston, is actually equipped with automated system. All right, so let's move on. So now I want to get to what we want to continue doing, and that is the section on system of nonlinear equations and inequalities. So what we have is something like this. Let me do this simple one here. So what we have is something like this. So we have a system, but notice that the equations, this one is linear, but this one is not linear. So that matrix business that we talked about doesn't work anymore. So what we have to do, we have to use the elimination method and the substitution method. Remember those 2 methods, elimination and substitution. So in this case, we can name these equations 1 and 2, right? So what we have is basically x plus y equals to 4, and then we have x squared plus y squared equals to 9. Now in the next chapter, we're going to talk about conic sections. This is a circle actually with radius 3. We could talk about circles, ellipses, hyperbolas, and parabolas. But in this section, we don't have to know what these are. We just have to try to solve it. I show you the graphs of these, but you don't have to know how to graph them in this chapter. So the way we do it algebraically is basically we move try to solve for one variable here and put it in here, right? So if we solve for solve for y, because this is solve for y here, so I'm going to do it so I can follow this. So we can solve for x and we'll put it for x, doesn't matter. So solve for y would be 4 minus x, and then we're going to take this and use it to change y here. And what you see is basically x squared. You're going to get x squared plus 4 minus x squared equals to 9. And this is nothing but a quadratic. You just have to expand it, and if you do, you're going to get this. So I don't want to spend time here simplifying a quadratic. You can do. So here you go, what you get is this, and then you have to solve this, whether using quadratic formula or factoring. In this case, it would be quadratic formula. So if you do quadratic formula, as you see right here, it's not a very nice number, but that's okay. Whatever it is, we can solve it. So x is going to be, well, you have it here, so I don't want to rewrite it. So eventually, inside the radical here, let's say inside the radical, so that's 64 minus 4 times 8, 4 times 2 is 8 times 56. And 64 minus 56 is what? Is 8. So that's the square root of 8, right? So that would be x equals to 8 plus and minus square root of 8 over what? Over 4, right? Well, square root of 8 is 2 square root of 2, right? So divided by 4, 8 over 4 is basically, that's what it is. So it's going to be that plus and minus 2. We can simplify it and make this, so that would be 2 plus and minus square root of 2 over 2, right? If you simplify it. So that's what we're going to get. Now, so x equals to two numbers. So we're going to come back over here and say, okay, we know that y equals to what? 4 minus x. So y equals to 4 minus x. So if that's the case, then when x equals to 2 plus square root of 2 over 2, then y is going to be 4 minus 2 plus square root of 2 over 2. And when x equals to 2 minus the square root of 2 over 2, then y equals to, get this, then y equals to, again, 4 minus 2 minus the square root of 2 over 2. So these are just two numbers, right? And these are ordered pairs. So there's going to be x, which is going to be 2 plus the square root of 2 over 2. And the y is going to be 4 minus, so let's see. If you simplify this, we get 4 minus 2 minus square root of 2 over 2, right? So 4 minus 2 is 2, so that would be what? That just would be y equals to 2 minus the square root of 2 over 2. And over here, y equals to 4 minus 2 plus the square root of 2 over 2. So y equals to 2 plus square root of 2 over 2, right? So one answer is when x is that, then y is what? 2 minus the square root of 2 over 2. And the other answer is that when x is 2 minus square root of 2 over 2, y is going to be 2 plus square root of 2 over 2. So these are two solutions for that problem. Now, let's take a look and see what they look like, right? So these were so what I'm going to do, I'm going to see if I can graph them and show you what they look like. So the bottom one is a circle and the top one is a straight line. So we are going to graph it like that. So let's do that. So the top one is just x plus y equals to 4, which is a line. And the bottom one is just x squared plus y squared equals to 9, right? And then what we have here, as you see, let me make it a little bit bigger. So we are interested in these two points. That's the intersection of this circle and that line. So if you find the intersections, let me do that. So one is going to be 2.17 and 1.29, which is basically the answer that we got here. So one of them is like 2 plus square root of 2 over 2 is 2.7 something, right? So that's the 2.7. And then this one would be 2 minus, so it would be 2 minus, let me put this over here so I can show you. So this one would be, this one's 2 plus that, so it's 2.7, and this is like 1.3 or something, right? And this one is 1.3 and then 2.7. So those are the two that we found, right? This one. You see, you just switch them. So those are the two solutions. All right, so that's how we solve systems of equations that are not linear. So we have to use either substitution or elimination. So let's look at another one. So for example, this one right here is easier to use substitution. See, this one right here, let me grab it so I can work with it. So this one right here, you see, this is a system. Let me put it here bigger. So y equals to negative x, and then again we have a circle, x squared plus y squared equals to 9, right? So you know, basically what we have here is a circle with a radius of 3, and then y equals to negative x is basically that, right? So the two solutions we're after are these two right there. And algebraically, this is really much easier to just use substitution. So y equals to negative x, so in the bottom one, all I do is what? Substitute negative x for y. And what do I get is basically this x squared plus x squared is 2x squared equals to 9. So x squared is going to be 9 over 2. So x is plus and minus 3 over square root of 2. And if you rationalize it, it's plus and minus 3 square root of 2 over 2, right? Now, we know what y is. So when x is, we know y is negative x. So when x is positive 3 square root of 2 over 2, y is negative 3 square root of 2 over 2. And when x is negative 3 square root of 2 over 2, y is positive 3 square root of 2 over 2. And so we get two ordered pairs, right, as solution. One of them is when x is 3 square root of 2 over 2, y is negative 3 square root of 2 over 2. And one of them is if x is negative square root of 2 over 2, then y is positive square root of 2 over 2. And that's all. These two solutions are actually these two. Alright, so either substitution or what was the other method? Yes, elimination. This one, you can do elimination, but is much easier to deal with substitution. So that's all there is to solving this kind of equations. There are a bunch of them in the text you can practice. And now I'm going to talk about inequalities. So what if we have inequalities? So let's talk about that. Now we know about one-dimensional inequalities, right? So let me grab this so we can write on it. So we know about one-dimensional inequalities. For example, if I say x minus 1 is greater than 3, what we know, this is x greater than 4, and then we graph it on what? On number line, because it's only one variable, and then we go to 4 here. We don't want 4, but we want everything to the right of it. And we are done. That's the solution. You can write it in interval notation. But what if somebody says y is greater than, let's say, x minus 1? Well, what do they mean by that? Well, how do we solve inequalities with two variables? Well, the method is very simple. First, we let it be an equality. Whether is equality included or not doesn't matter. So first we let it be equal to, and then we solve the equation. Now here we can do this. I'm going to show you how we can use the same method here, but let's follow this first. So first we turn it into an equation, and then we graph it. Now remember, here we graph the solution because we had one variable, so we have what? We have one line, but here is two variables, so we need two lines. So let's graph that. So we graph what? We graph y equals to x minus 1. Now, so step 2 is to graph what? Graph the solutions. Solutions to what? Solutions to this equation. Now, graph with solid line if equality is included here. If we have this or this. And graph with dotted line if we have this or this, right? That's it. That's the step 2. So let's graph this. So to graph this, I need 2 points. I need to go to y-intercept, and then the slope is 1, so I go up 1, right 1, right? That's another point. And then to graph this line, I'm going to use a dotted line. There. Okay? So that's that line. Now notice that the line divides the plane into 2 parts. So step 3 is to test point. Test point. Test points. What do I mean by test points? That means you go to one side of this equation, of this line. So right here, I pick a simple one like this point right here, which is 0, 0, because it's easier to check. So this is my x, this is my y. So what I like to know is whether this point satisfies this inequality. So if y is 0 and x is 0, does it satisfy? So I'm going to check 0, 0. So yes or no. Well, let's see. 0 greater than 0 minus 1. So 0 greater than negative 1. Is it true that 0 is to the right of negative 1 on the number line? On a number line, 0 is here and negative 1 is here. Is 0 to the right of negative 1? Yes. 0 is, you can say, greater than negative 1. So that means this point is actually good. If it's good, we shade the whole area, the whole part that point is coming from, right? Remember, this divided into 2 parts. And then pick a point over here and test it. Now we know this is negative 1, so we could pick this point, which is what? 0, negative 2. Does that work? So let's test it. 0, negative 2. Does that work? Well, let's see. So we're going to do what? We're going to do negative 2 is y is greater than 0 minus 1. Negative 2 greater than negative 1? No. So that's one, that one does not, so we're not going to shade here. Okay, that's how we solve an inequality, right? Now what if we have two of them? What if we have two inequalities? Let's say somebody says I want y to be greater than x minus 1, and I want y to be less than or equal to, let's say, 2x, something like that, right? Now if we do this, then we have to do what we just did twice, and then look at where the regions that we like overlap. So let's do that. So to solve this one, we have to graph what? Y equals to x minus 1. That's the step one, right? And then for this one, we have to graph y equals to 2x. That's the step one for this. And then what? Then we're going to have to graph them. So let's graph them over here. Let's graph them over here. So y equals to x minus 1, we already know is here. We go up and write 1 here. And since equality is not included, I have to graph a dotted line. And then I have to what? I have to get a test point, right? So I graphed it already. Now I'm going to get a test point. So I got we just did that, right? So we could get 0, 0 here. And we know 0, 0 is yes. And then if we pick this one right here, maybe 0, negative 2 is not going to work. And we just did it. And this one is no. So the first one, we have to shade here, right? We have to shade here. All right, so that's the solution for the first one. What's the solution for the second one? Well, we have to graph y equals to 2x. Now y equals to 2x is a line that goes through the origin. The y-intercept is that. And then you go up 2, and you go right 1, right? So it's right there. Make sense? It's kind of right there. So up 2 and right 1. And since equality is included, I have to graph it with what? With a solid line. So I'm going to graph it with a solid line. Come over here. There, right? All right, now they do intersect here, right? They do intersect. So what I'm going to do, I'm just going to maybe change the color and get a blue one, so I can actually do a blue. So this line I'm going to do it with the blue one. Okay, now this line, the blue one, also divides this into two parts. So we cannot use 0, 0 anymore, so we have to pick a point on this side for the blue one. So let me pick this one, which is 0, 1, right? So I'm going to test 0, 1. Is it yes or no? Well, we have to put it here. So if I put 1 for y, is it less than or equal to 2 times 0? Well, 1 less than 0. Is 1 less than 0? No. So that doesn't work. So that's a no. Now, what about another? Well, let's pick. This point is good, is to the right, to below the blue one, so we can pick this one, which is a 1 here, right? Because when y is 0, x is 1, that's a 1, right? On the red one. Okay, so let's test that one. So we take 1 and 0, and we test it. So in this equation, if x is 1 and y is 0, we get 0 is less than or equal to 2 times 1. Is that true? And the answer is yes. So for that one, we say yes. And so what we have to do is what? We have to shade here, right? We have to shade here. So the solution is really this area right about here, right? That area, because that's the overlap, right? So the solution is really from here all the way, well, I shouldn't have done that, is a dotted, right? So this border has to be dotted, but the other border is actually solid, right? So you see that shape right there with dotted on one side, right, and solid on that side. This right here is the solution because it's the overlap. Now remember, this has to be dotted, dashed, and that has to be solid. So all the points in here satisfy this inequality and satisfy this inequality. So that's how we deal with system of two inequalities. Now let's do one of the problems here. So let's see if we can find a good inequality to solve. So here is 1, it's just 1 instead of a system, so we can look at it. So again, how do we do it? Well, let's get this one. You can do both of these actually. So where did it go? I lost it. Oh, here we go. All right, so here we have what? We have x squared. Let me get my red pen. So we got x squared plus x squared plus y is less than 9. So what we have to do is, first, again, step 1 is what? To turn it into an equation, which means y is what? Negative x squared plus 9. Now we know negative x squared plus 1 is basically you flip x squared, which is a parabola like that, you flip it and then move it up 9 units. So that's what you get. So flip it and move it up 9 units. That's what you get. And then you graph this. Now we know if y is 0, we have to graph it, we have to know the x-intercepts, right? So if y is 0, then x is, this is negative x squared and plus 9. So if y is 0, then x squared equals to 9, so x is plus and minus 1, right? So x is plus and minus 1. So plus and minus 3, what am I saying? Why 1? All right, so it's plus and minus 3. So these are the two x-intercepts, and we know this parabola opens down. So now we graph it with what? With a dotted line, as you see, right? Now, this, again, parabola divides the plane into two parts, inside here and outside. So we're going to pick a point inside, let's say 0, 0. So the second step was to graph it, and we did. The third step is to test points, 0, 0. Is it yes or no? Well, let's see. If I put a 0 here and 0 here, that was 0 plus 0 is 0, less than 9, yes. So that means we have to shade what? Inside this parabola, and that's the solution. All the way to what? This way. These go forever, and this area extends. Okay? So this is another one right here. This one is x squared plus y squared is less than 4. So first step is to turn it into an equation and graph it. Well, this is a circle. I think you learned that in college algebra. So that's a circle with radius 2, right? And the center is at 0, 0. And since the equality is not included, we have to graph this using what? Dotted line. And if you do that, you kind of get a circle. And then the circle divides the plane into inside the circle and outside. And what you do is you get a point inside or outside, doesn't matter. So the second step was graphing it. The third step is test point. So 0, 0, if I put 0 here, 0 here, 0 here, 0 is less than 4, yes. So we shade here. You can also check outside. You have to check both sides, but it's possible that there are all solutions. So you always have to check one from one side and one from the other side. So let's test another point. So we know this point is 2, so we could test this one, 3, 0. So does that work? Well, if I put a 3 for x and 0 for y, that would be 9 less than 4, which is not true. So we don't shade here. Okay, so these are inequalities. And let's go to a system of inequalities. If you have a system, is that a system of inequality? Yes, so this one is a system. So what we want here, so what we have here is a system. So we have x squared plus y is less than 1, and we want y to be greater than what? 2x, right? So we got to solve this. So we have to do x squared plus y equals to 1, and then we have to do y equals to 2x, right? So let's do the red one first. So x squared. So if I want to solve that, I could just do what? Do y equals to negative x squared plus 1. Now again, we know what that is. Negative x squared plus 1 is what? Is this parabola that is flipped and then moved up 1 unit. So here's 1. And now what is the x-intercept for this? If y is 0, then we're going to get x squared equals to 1, so x is plus and minus 1. So x is plus and minus 1. Okay, it doesn't want to do it. Let me do it here. How does it do that? Well, all right. So well, let's just leave it there. That's okay. Now equality is not included, so I have to do what? I have to do a dotted line. I'm going to do a dotted line like this. So that's my parabola. Now we have to get a test point. So that was the we did the first one, we did the second one. The third one is to do the test point. So we need two sides. Let's pick 0, 0. Right? So 0, 0. Does it work? Well, let's see. If I put a 0 here and 0 here, 0 plus 0 is less than 1, yes. So that means inside the parabola is good. So I'm going to say this, we do 1, right? So I want to shade here inside the parabola. All right, now I want to switch to blue and graph this one in blue. So first we do y equals to 2x. That's the first. What happened with my blue? All right. All right, so y equals to 2x. That's the first step. And then we have to graph it, the second step. We graph it. Y equals to 2x. Well, to graph it, I know there is y equals to x goes over here. I know this is 1, so this is 2. I know this is 1, right? So it goes over here. And equality again is not included, so I'm going to have to do what? Do a dotted line. My pen is right there. Now notice that there is an intersection here. I don't know where that intersection is, so we should find it. So to do the third one, we don't need to know that intersection, but we're going to find it. So to do the third one, the blue one divides the plane into two parts. So let's pick like this point for sure is to the, above the line, and that point is 0, 2, right? 0, 2. So now, does it work for this one? If I put 2 for y and put 0 for x, is 2 greater than 0? Yes. So that means I need what? I need that part of this line. So you see where the overlap is, right? The overlap is like this area here, right? That's overlap. Okay, now we could have, with the technology, of course, we can easily do these things nowadays. So let's do it with technology here. So what I'm going to do, I'm going to basically graph this. You see, I'm going to put x squared plus y less than what? 1 there. And that's GeoGebra, of course. And then y is greater than what? 2x there. And if I change the color of this, maybe to another color, maybe red, then you see that the solution is really this overlap right here. That's the solution. Now the intersection, how do we find the intersection? Well, you have to find the intersection between this and the line, right? So with the GeoGebra, of course, we can do it, but algebraically, how do we find the intersection of the two? Well, what we want is we have to solve for y here on the first one. So if we solve for y for the first one, we get y equals to that. And for the second one, y equals to that. So now to find the intersection, we want the y's to be equal. So that means we want negative x squared plus 1 to be equal to 2x. So if I move everything to this side, I'm going to make x squared plus 2x, because 2x is already here. I'm just moving these to this side, right? And that would be a minus 1 equals to 0. So that is what? That is just, how do we solve that? Well, can we factor it? We need two numbers. You multiply, you get negative 1. You add, you get 2. Well, x minus 1 and x minus 1. Well, wait a minute. I think I did something wrong. What did I do? Let me do it here one more time. So I want to find the intersection of, so y equals to, where was it? Negative x squared plus 1, that's correct. And y equals to 2x, right? So intersection of these two would be, let me go back to my, so let me find the intersection right here. So would the intersection be of that one and this one? Well, it doesn't find it because I put them in form of inequalities. But algebraically, you just set them equal to each other, and you get the intersection. So y equals to negative x squared plus 1, negative x, and then y equals to 2x. So x squared plus 2x minus 1 equals to 0. So what do we get? We get x squared, x equals to negative 2 plus and minus the square root of 4 minus 4 times 1 times negative 1, right, divided by what? Divided by 2. I was doing something wrong here. Yeah, I know what I was doing wrong. All right, so we get what? We get negative 2 plus and minus square root of 8 over 2. So we can find the intersections of these two numbers. They're not nice numbers, right? So so we get some irrational numbers, right? But if we don't really have to know the intersection in order to find the solution. All right, so what I was doing wrong was that I was factoring this wrong. Okay, don't tell anybody. Okay, so let's look at another one. We got many of them right here. You can practice. Now again, I don't want to do more of these until we get to the next chapter. Okay, next chapter we understand, you know, parabolas and ellipses, so we can intersect them. But for now, we're going to wait until next section. All right, so let's stop this video now, so we can continue with the next chapter. Okay, and I hope again you're doing well, and I see you in the next video, and take care of yourself and others.